admit all.
You can see the screen, I hope.
Yes, sir. Yeah.
Okay, good, good. Shall we start? Because we are already 15 minutes late. Sorry for the delay. We had a special discussion before that. Can you all hear me? Is it audible enough? Don't wait until the others answers. You can decide on your own. Say yes. Don't worry.
Yes, sir, we can hear you.
Okay, good, good. Now this seminar series, as I explained to my group the other day, is outside our regular lectures and other things for this module. So this is not specially designed to learn solid edge, but to support to complete your module ME32CC though, I'm going to organize this seminar series. But those who are attending and listening to the seminar, and you can of course start learning solid edge as well by going through this one. Initially, I decided to have it as seminars, maybe 2-3 seminars to give you the background. And after that, I will move on to the regular classes where some assignments will be given. So the marks also will be given for your effort. And then that way we can monitor your progress as well, right? So let me start because it is already late. So this is my plan actually. I have basically divided this one into 3 sections today. First, I will give you a little bit of knowledge. I mean, you should prepare for learning, and also you should know why you should learn, what should I know, and all these things. Otherwise, I could straight away go into the solid edge, but then sometimes you don't get that solid foundation of the identification of why I should choose SolidWorks or solid edge, or maybe even any other software. And then I will want to 3D modeling as well. Why do you need 3D modeling? Or what are the other alternatives available? Maybe a little bit of history for you to be aware. I'm not going to go into the details, but maybe when you have time, you can go through the history as well. That evolve or the development is also very important for us to know. The technology is moving very fast. You may lose track of all these things unless you follow all these things. All of a sudden you start something, but you may need to understand what happened in the past. And then I will move on to the solid edge for 3D modeling. Today I will give you a very brief introduction to solid edge, and then show you how to model simple parts so that you can practice until I start the second seminar. And after that, it will be completely on solid edge, right? So let me start. The skills that you should have. Maybe you are thinking that you already have the skills, right? But excuse me, Hill, Dr. Hill,
Sir. Yeah. Yes, sir.
I have some polls created, but I can't see them here, no? Because you started it, no?
Sorry, sir. What you created?
I have some questions like polls, the polling in.
Okay. Maybe. Wait. Let me make you host.
Yeah, try this. Do I need to restart? I don't know.
Okay. Now you try.
Still, I couldn't see that one. Let me see.
Oh, then. Yeah. Shall
Maybe,
we?
maybe I will. If I exit, there'll be a problem, no?
Yeah. Then someone else will be. I mean, I will be.
Let me see. Let me see.
Okay.
No, not that coming. Maybe when the time comes, I will start again, right? So that you can join again, no?
Okay.
Right.
Okay.
First thing is your ability to visualize. You know, you are doing something which you can't see, which you haven't seen. Someone has never done it, right? So in that case, your visualization skill is the number one. If you can't visualize, you may not be able to do designs, especially for new products. New thinking has to be there. First, you have to visualize, right? So this is very, very important. Let me check, very simple, right? This is not a question, but let me see. There's a certain product which will give you front elevation like this and also a plan view like this. Identical, let's say. Dimensions are not given, but you can assume that one is identical, right? So the front elevation and the plan. Now my question is, can you identify this product? What this product is? Start thinking, right? I'm not going to get you answers yet, but I want to see whether it is possible for you to visualize. If you can identify this product, then see whether you have the answer for this one, right? There are no hidden lines, otherwise there will be endless number of products. There are no hidden lines in this particular thing. If yes, if you identify the product, then can you draw its side view? If possible, draw the side view. If no, then you should have answer. Why? Maybe you can say, I don't know, I have no idea. Or maybe there is something missing in this particular thing. Or maybe there are more than one product. In that case, you must tell, or you should be able to identify how many products are possible that will give you the same front elevation and the same end elevation. Now I will show you the results or the answer, so that you can compare with your imagination or what you have visualized, whether it's going to tally with this one. Of course, there may be even something else as well. So this is the first one. Obvious, you can say the trivial condition is there. It's a cube, right? And then could be even a cylinder. You see now the front elevation and the plan is not changing, but the end elevation and the isometric view is changing. This is the second product that will give you the same front elevation and the plan view. So you might ask some questions. I said no hidden lines, but there are center lines here. Remember, hidden lines are something which is existing in the object, physically they are, though you can't see them, but center lines are imaginary lines, which we introduce when you prepare the 2D drawings. Otherwise, in the 3D model of the product, there are no center lines, right? So this is for technical purposes, right? So that is why I didn't include that one there. Hidden lines are actually physically there. Okay, the third one, you can make it like a semicircular part. In that case, what will happen? The height will change. If I want to maintain the same dimensions, then make it like a little bit oval. So that is the third product. And let's say the fourth one. You have two straight portions as well as the semicircular part. The previous one was completely oval shape, right? And then this one will also give you the same front elevation and the plan view. Anything else? Some more? When you discover, identify one possibility, then you should start thinking on that line, and then you should be able to identify something else. Don't assume the product is like this, then start imagining. You have to free your mind. Otherwise, you won't be able to identify the possibilities. Once you get one or two, then your thinking process locked. You will never be able to get anything out of that one. You can see still you have something. So I derived the last three from the same thing, right? So for example, if I go back this one, and then this, if it is possible, why not this? If these three are possible, then why not this? You can try, you can even do a 3D model and see they are going to give the same front elevation and the same plan view. So if you include the hidden lines, and there will be endless number of products. So why it is important? Because this is where you're going to start communicating. If you can't see what exactly that you're going to make or what you're going to design, you won't be able to model it. You know, the specialty in this engineering drawing and the communication, not like in any other communication like this is unique and definite. There can't be any ambiguities. There can't be two products from the same drawing. If it happens, then there is something wrong. Maybe the person who created this one done a mistake, or maybe your knowledge is not enough to interpret what is given there. All these things you should have kind of as a skill. Okay, let me go into a different thing now. That was from 2D to 3D. Now this is from 3D to 2D. Right? It's a simple product. Of course, there are more complicated products than this. That is also possible. Because what you see, everything is on a flat screen. And compared to that, what we have in our physical world is everything is 3D. Everything is 3D. There are no 2D objects which you can physically touch. Right? Maybe thickness may be very, very thin, maybe unusable, but still there is a thickness. Right? What happens if the thickness is zero? You will not be able to see that one. There is no such product. So everything is in 3D. So this drawing is a way of representing 3D objects on a physical, on a 2D sheet, because the thickness we can't use. So depending on what you see on the screen, you should be able to visualize and identify whether there are some mistakes, whether there can be multiple combinations of that one. Right? This is simple. I think you should be able to do this. Right. So what I want to highlight by giving that one is, you see, in the first line it says in first angle projection. So you should be able to understand what is the difference between the first angle projection and the third angle projection. If you make a mistake, that's a big mistake, not a simple mistake. Please understand this. Right? Now you decide what you have done in your semester 2, maybe after that. We have given you the completed 2D drawings. The views are in the right positions, right dimensions were there. Everything was almost complete. You need to reproduce that. But starting from this project, the components are yours. You design them, and then you have to dimension them. You have to generate the views. Which view that I should select as the front elevation, end elevation, plans, if not enough, sectional views and other things and like that, because the product is yours. In that case, you need to identify the minimum number of views, right? And then how many additional views are required? How should I dimension it? I'll come to that point a little later. So if you interchange these things, your interpretation will be completely wrong. Now I said about first angle projection and the third angle projection. Have you ever wondered why we are not using second angle and the fourth angle projections? What could be the reason for that one? We use first angle and the third angle. What are these angles? If you divide the circle into 4 quadrants, these are the first angle, second angle, third angle and the fourth angle. First quadrant, we call it first angle. Second quadrant, I don't know, we are not using it, but for why? Third angle, of course, we use. You need to know both, because in some countries they use third angle projection, and in some countries like Sri Lanka we use first angle projection. Sometimes you have to communicate between different countries. So you should understand exactly. If I am going to receive a drawing from them, what is the projection method, that you have to indicate in your drawing sheet. If it is not there, that's again a big mistake. That's again a big mistake. And you can't mix up, right? You can't mix up as well. So these are some of the skills that you have to develop. And then visualize something totally new. How do I start developing this? We are not going into that much of details, but anyway, still you have to think, for example, your gearbox. How should I, what should be the shape of this one, the size of this one? Where do I place the elements inside that one? Where do I place the gear shifting lever? In which orientation and all these things? It has to originate from your mind. And then you should be able to transfer that one onto a piece of paper like this, freehand sketching. Why? Because you need to communicate with the others. You need to get the comments, feedback from the other team members as well. From this year onwards, you are trying to make it like an individual project, but still you can communicate with your colleagues. Ask them. If you can't put your idea into a picture like this, very difficult to move forward. You may draw it, maybe not like this, not nicely like this, because that's a kind of a skill that you have to develop. But at least if you can see that I can communicate, that the other person can understand without any ambiguity, that is what you need. So then only you will be able to come out with your, what you call the final product. It could be of different shapes, different size and appearance and everything. So this is where sometimes we use even 3D modeling. Without making the physical product, how do I get a complete idea, except that product is not tangible, right? And then of course your freehand sketching. Apart from that, this is a different level, not mechanical, but it's still important. This is something like perspective drawings. What you saw earlier is a what? Orthographic projections and isometric projections, right? Parallel projections, both are parallel projections. So this is perspective projections. Architects especially use this one. And then we have even the bird's eye view, right? And products could be anything like that. Right? You should be able to, communicate with others. This is my initial idea before you go into the details. You can't start producing a drawing because you don't know the dimension, the sizes and other things you don't know. This is the only way to communicate. Can be any product. Can be any product. This is to communicate with the others. Right? And then of course you should know about your engineering drawing. Bit technical, the manual drawing. Though we have AutoCAD like software, today we can completely forget about your manual drawing board, but that interaction is the important part. The thinking process. The information should flow through your mind, not from the piece of paper to the computer. So most of the students are doing the second way, from the paper to the computer. Maybe you have put your headphones on while listening to the music, you try to do that one. That's not the right way to learn this, and it has to be absorbed by you, right? So this is the manual drawing part. You need to have some kind of an idea about this one, manual drawing. We use different instruments and everything. Because you have to think. Before you draw this line, you have to think. And then only you can convert into a line or not. And then of course, with the technology we are moving forward, now you need to know even computer-aided drafting, we call it. Computer drafting. How do I use simple package like even Word? You have to identify whether Word is suitable to produce engineering drawing like this. Or maybe even AutoCAD, because they are widely used in the industry. They are widely used in the industry. If you are used to Solid Edge or SolidWorks, sometimes to produce a simple 2D drawing, you can start creating a 3D model and then generate the 2D drawing and then give it to them. You're wasting your time. Yeah, wasting your time. For some, you don't need. 3D modeling and 2D drawings are two different things completely. Today we talk about paperless manufacturing, where you can exchange your CAD data with the manufacturing systems in the CAM part, where you don't want to produce these hard copies and the 2D drawings and other things. But still, in most of the places, even in the most developed countries, they still use these 2D drawings to communicate with the different levels. Right? So don't think that the 2D model can replace your 3D model and then 3D model can be replaced with your 2D drawings. So you need to understand all these things. And then, especially for this particular thing, for mechanical engineering, you should know what are production drawings. I just give you a bit of a sample. Now you can see, in addition to the dimensions, you have a lot of other information are given here. Suppose you are the one who is going to design this. In your gearbox, you have a shaft like this. Nobody will give you all these dimensions and the other information like tolerances. There are two types, geometrical and the dimensional. Nobody will tell you, you need to put dimension here, you need to put a tolerance here, whatever it is. Or even how many sections, the orientations and everything. You need to decide on your own. For that, you have to understand what is a production drawing is. And applying dimensions, also you need to learn something more as well. So this is the time that you really put yourself into practice. See whether you can identify the requirement and produce something like this. Otherwise, what happens? This will go into the manufacturing division, they will start manufacturing and then send you the part in the assembly division, and you can find that they are not going to match. You can't assemble them. You know that aircraft are manufactured in different countries and different places, not like a simple product. If one made a mistake, what will be the cost? Can imagine, right? So you can't do mistakes especially in the engineering design and the engineering drawings. So you should know how to create this drawing and how to interpret also. Maybe the drawing is not mine, someone else has created this one. Or maybe a person in a different country where you can't speak each other's language. How can I send him an email and ask for clarification? How can I communicate even over the phone? Because we can't understand each other's language. Or if you are sitting in your office as a design engineer, maybe your subordinate might bring the drawing to you and ask from you, I can't understand this. Can you kindly explain me? You can't say, I don't know, because you are at a high level. You are labeled as an engineer. You can't say, I don't know. And at the same time, you can't just assume and tell him something. It has to be perfect, exact. No mistakes, no doubts. Right? You can't refer books suddenly and Google it and find out those information. Right? So that kind of knowledge, it's the practice only will take you, will be able to acquire all these things for you. And then the creativity. I'll just give you a simple picture. Perhaps you might remember your childhood. I don't know whether you have played with this one or the mobile phone and tabs or even the TV. Our time even we didn't have such things. We had different things. We made our own what you call the building blocks and then come out with different products. You see, it is the same set of building blocks, but you end up with different products. 3D modeling is still the same. You have your building blocks. When you look at the building blocks, you don't see anything. If you can visualize how I can select the parts and then combine them in whatever the order I want and then come out with different things, that is your creativity. You need to be able to even visualize as well. If the small kids can do that, Why not you? You should be able to do that. Right? If you don't have that experience, maybe before soon, buy one of them. It's not that expensive. Try on your own. You will see, you will understand how difficult. And moreover, one who design a set like this, definitely it's not a kid, no? So that you will be able to come out with different products and different models and various things. How do I design my building blocks? That is very important. So again, what is creativity? Some of the captions that I got from the internet. You see, the logic will take you from A to A to A or Z or whatever it is, A to B or whatever it is. But imagination will take you everywhere. We have the logic. As engineers, we know how exact to work according to a certain logic. But that won't help you to improve your creativity. Right? Look at the last two pictures. Someone is crazy about creating those things. You might have some sort of a creativity and identify it. Maybe not exactly as this. Some sort of creativity means your mind is working. That is what is important. Like this, for example. Nothing to do with any technical terms or anything. But they are also creativity. They are creative people. Creative people. How can they do this with the minimum use of technology? That is what you want to know. As engineers, don't just become kind of what you call the theoretical engineers. Right? So if you can't figure out how these people even made those things, you see that means those fellows are better than us. Right? Very difficult otherwise. Again, very simple thing if you can't understand all what I have told you right now. Ingredients and vegetables. You know what I'm going to ask next, right? How many of you can cook? Different ways? But it's the same ingredient and the same set of, the food, the vegetables and other things. You're going to create two different things. The solid modeling is also the same thing. You have the same ingredients, you have the same set of tools, but your end product would be different. That's your creativity. That's your creativity. If you want to have a simple thing like that, it is still possible. But if you have the that imagination power, creativity, then you can end up with your limits are endless. I mean limitless actually. Maybe I will clarify it further. When it comes to technicals, we have a lot of software. Some people are thinking SolidWorks is better than AutoCAD. AutoCAD is better than SolidWorks. Or Solid Edge is better than SolidWorks. And you try to, have a kind of an argument because you are familiar with one software but not the others. Maybe you have even never heard about those things. So you try to promote your work. But all these things are what? They are just tools. They are just a tool. Nothing else. So you can end up with creating a simple products like this. So you can use any of these software without anything. And also, bit of creativity, you end up with something like this as well. Right? That is creativity. If you go to the internet, you can find a lot of them. Spend your time on, reading those things, identifying those things. What is the difference between the first one and the second one? So then you are developing actually part of your brain where your creativity will be improved. And also your problem solving approach. there's a problem that I need to solve. I need to find out some solution. So how do I do that? You're arrogant, hot-tempered person, you can't communicate with other persons, your PR skills are very poor, you will not be able to get the help from the others to solve the problems. It should be systematic. You need to get the others' support as well. Don't think that I can do everything on my own. The ideas of other people. It doesn't matter whoever it is. Could be an engineer, could be a senior engineer, could be a doctor, professor, or it could be even a layman. Or if you are working in the university, it could be even a person who is cleaning the toilet. You get the idea from them. Because their thinking is different than yours. So if you can collect them, then you will be able to solve the problem without any trouble. And then your practicing is the most important thing. I know everything. Everything is in the book. I have a collection of videos, collection of tutorials and everything, nicely organized in the soft form in your computer. But you are not practicing. You are not practicing. Then it is useless. Then that is useless. So you need to identify the right techniques. You have to follow the right techniques. Because you are practicing. When you keep on practicing, it becomes a habit. It's very difficult to get rid of habits. So my advice is to follow the right technique, no matter whether it is a simple part or a complicated part. Always follow the right technique, so then it becomes a habit. Then you don't want to put any effort. Some people create models and drawings assuming, oh, this is a simple part, no, I can do like this and then just like this. When there's nothing remaining in your mind. Let your brain also learn. Right? So you need to follow the right techniques. And definitely do not compare yourself with others. They are different. Individuals. Don't try to compare. Oh, that person can do better than me. And I have higher, what do you call this, GPA than him. But I can't do this. Don't compare. Don't even think about that one. Identify your strength, your weaknesses and everything. Be on your own. Right? Otherwise, it's going to be very difficult. And then, of course, you need to practice frequently. Don't make it a kind of hard work for you. You can leisurely do this. While enjoying this one, you can leisurely do this. And then try out different ways. This is, most of the students are not doing this one. They get satisfied the moment you see something on the screen. See whether if I can do this one in a better way, then you should try it. While doing so, you will be doing a lot of mistakes, and that will help you to identify or absorb the content very well. Because the software is a tool, I don't know how exactly I should use that one. Nobody can give you everything in a software. Even the developer will not be able to do that one. Or maybe something that even the developer has never imagined can come out from a user. Because their thinking is different. You are just manipulating the tools and then come out with something new. And of course, you need to develop your own way of modeling. It has to be the right techniques, you have to follow the right techniques. And based on that, you develop your own way of modeling. If you can do that, solid modeling is not a difficult task. Whether you start with AutoCAD, SolidWorks or any other thing, it will be the same. It will be the same. But don't do these things. Right? What are these things? During a lecture, I don't know because I can't see your faces and everything, don't sleep. You relax. One reason for you to relax or maybe not attending lectures, because for sure you are going to get the recorded video of this one. I usually don't give, but sometimes you can record on your own. I don't mind that one as well. Because you know the situations are different. The present situation today, you will never get that one back. You need to learn just now. not tomorrow, not day after tomorrow, not when the exams are close or when the deadlines are close. It is not the right way, right? So this is what we call this active learning, right? But what is happening here is not active learning, but it is active sleeping, right? And also, in most of the classes, I think most of our staff members have experienced this one. When you say, do you have questions? No answer. We ask again and again, any questions, any more? Still no answers, still no answers. So then we used to say, otherwise, we feel like, embarrassed like thing. Okay, we say, oh, it seems that you all understood the matter. Right? The other one is nobody can understand the matter. And at the end, behind the scene, what could happen? You're asking from someone else. Your mom can't help in this one. Your father can't help in these things. Right? You should ask questions. It doesn't matter whether you're going to make a mistake, big mistake in asking the questions. Whether the forming the question, the English or the grammar, whatever it is, don't worry about those things. Get used to these questions, right? And then, of course, before I continue, do you have any questions to ask from the things that I have already covered? That's the proof, right? What I have displayed in the last slide. Okay, I'll also do the same thing. So looks like that you have understood the matter well. So then I will move on to the next slide. Just a few thoughts to remember. Right? Teaching is useless if learning does not happen. We do the teaching and you do the learning. No matter how best I deliver my lecture or how worst I deliver my lecture, from your side, learning should happen. Otherwise, there's no point. And also, improve your power of imagination and the curiosity for learning. If you are not curious about the learning, then that is again useless. If your objective is to get through the exam and get a A+ or something like this, once you achieve your objective, that thing will be over. No more interest in that one. The learning is a lifelong thing. You are learning not to earn marks or earn a good grade. That will be kind of an outcome or maybe an output of this thing, right? But never learn to obtain marks and awaken your power of creativity. We have it. But our mindset, our creativity is blocked. One main reason is maybe you don't agree with me, most of you, the social media and other things. Right? If you go there, you can see even in Facebook, there are people has done some nice creative things. But what most of us are doing is we enjoy them. Right? Those who are doing that one, they are improving their creativity. Good side of the social media. The bad side of that one is you just, share those things and then count the number of the comments that you get. That's not the right thing to do. And teaching, watching, listening, and even doing many other things may facilitate your learning, but will not make the learning happen. The responsibility is on your shoulders, right? Visualize the things ahead of you. Perhaps you have never seen them. Of course, you can take some examples from the past, but not copying. Right? You just use your experience. And there are no laid out learning paths that everybody can follow. if you go to the SolidWorks, you see the learning path and whatever it is. They're just going to initiate, otherwise nobody will start using the software. But for you, it may not work. You need to follow a different path. Education is not a kind of a production system. It's a kind of an organic system. There are differences. Individuals are different. The way you learn, your skills and everything are different. So identify them and then work accordingly. So the learning should happen now, just now, but not tomorrow or someday in the future. So don't forget, right now, as I move on, try to understand the things. So I'm just preparing you to learn something much more important in your lifetime. Right? Without them, again, the last one, the best students are not always the creation of the best teachers, and also the opposite. The worst students are always not the creation of the worst teachers. Right? So remember this. So what you mostly do is you maybe attend lectures, maybe reading books, or you watch the recorded video of this thing. You see how much you can keep in your mind, memory? 20 to 30%. But look at the bottom list. If you start teaching someone else, it doesn't matter whether the person is interested about this thing or not. Get hold of maybe your grandmother, grandparents, whoever it is. Doesn't matter. Ask them to sit and then start teaching them. Right? So then that will put you in a experimental level. If you can explain, if you can describe, that means you have already got it, that one in your memory. Otherwise, no. So that's why we are asking you to ask questions. Otherwise, no. Right? So, in brief, don't expect from us. Yeah, you can see almost the entire department is supporting this particular module. Right? But don't expect from us what? That we will push you from behind to achieve your targets. That's not the right thing to do. Right? But of course, we will be there for you to support. It's not that I'm pulling you up, I'm holding the rope, so you should climb up. Right? I remember even the first day, first meeting, the students were asking many questions. Why do you undermine your ability, your skills, and your strength and everything? The many things I remember was asking about the extension of or the submissions of whatever it is. Don't do that, right? Then you will not build up the confidence. You put your own caption over there, whatever that fits you. It's a challenge. If you make a mistake, then you're finished. But still people do challenges like this, more dangerous than this. So what you are taking is not that dangerous. Take the risk, right? Right. Again, any questions? Next we move on to the computer-aided 3D modeling. That is the part B of my seminar, first day seminar. We need to understand what this 3D modeling is all about. For that, of course, maybe we need to go a bit of history as well. It's a branch of computer graphics. Applications are there, developments are there. Right? Someone who can prepare this, the package, SolidWorks, SolidDejo, or even AutoCAD. And maybe set of other people are using them. And maybe somebody else will prepare the hardware for that. Everything together, we will have a system. Right? So this 3D modeling is actually a branch of computer graphics. Computer graphics is a much wider thing. So we use 3D modeling for our design and simulation work. Right? Apart from that, there are many other branches are available. So it's just an idea or a concept that you're going to represent in the computer. Could be any physical object as well. The first thing could be an idea, the concept. Right? How you going to represent? It depends on you. If the others can understand what you're trying to tell, that's good enough. That's good enough. Right? It could be a product or a very complicated system. What you do is you're just going to represent that one in the computer interface so that others can visualize. You can share this one. You can share this one. But the difference is what, especially for 3D modeling, for our purposes, for design and analysis purposes, we use them as a mathematical model or mathematical data. We represent them in a mathematical form. Unfortunately, when you see the numbers, you will not be able to understand anything. So you convert that mathematical model into a graphical model, colorful, with shades, lights, materials and everything, so that anybody can understand, anybody can visualize. For in our case, 3D modeling is, in a way, it's a mathematical model, not just an image or a snapshot, like something you take from your camera. There is much more than that one. You should be able to process the data and then come out with something else. So for example, I want to see the internal view. If you section it from a section plane, what would I be able to see that one? So the idea of 3D model is that one. Perhaps as the creator, you can understand it. But now you are trying to explain it to someone else who has no idea about 3D modeling, what this product is. So for example, your product, you're now going to market it. You need to find an investor. He has money, but he can't understand this technology and everything. So you need to convince him. How? This is computer graphics. Right? So if you fail in that one, no matter whether your design is the best design or something, it's useless. And it's used in almost everywhere nowadays. And the other one is developing very rapidly. In early 80s, it was very difficult. I show some images. But today you can't even imagine how far it has developed with a very, short time period. And there are a lot of software and hardware tools available. Software and the hardware tools as well. Some are purely graphics, some are mathematical models. So that's what I'm going to tell you next. You can represent your object, your idea in the computer mathematically as a wireframe model. What is a wireframe model? That is how people started. It's only the skeleton of your product. Nothing else. No surfaces, no material inside. You can't see the surface properties, whether it is flat or curved or anything like this, or whether it is smooth or rough. You can't see anything like that. But you can get some idea. Better than nothing, right? Better than nothing. The advantage was you could see the product from different angles. If you want to do it in your physical life, then you have to make a prototype or model at least. Otherwise you can't. Otherwise you have to create too many pictures like that. That takes time. Right? So this is how they started, people started. And then surface modeling. I'm just going to give you very briefly. They realized the deficiencies in wireframe representation. And they try to cover those areas with some surfaces, but still nothing inside. That is what we call the surface modeling. So surface modeling, you can have analytical surfaces. So for example, if you have a circle, or for example, cone is a kind of an analytical surface, where you can define it from fixed set of equations. or else you can have even free-form surfaces. Most of the time the products are developed today with free-form surfaces. There's no any specific form or equation in that one. That's why you see a lot of aesthetic shapes coming up today for every product, free-form surfaces. And then of course you can have even sculptured surfaces, like statues for example. That is something slightly different. So we use different modeling tools and techniques to represent those things in the computer. And in all these forms, they are stored as mathematical models. Why do you store them as mathematical model? Because we want to open it later and then process it and then convert it to something else. Or maybe we need to calculate the mass properties, the surface area and other things. From just a model, from an image, you can't do all these things. And then people start making the solid models. A complete representation of your object, a physical object in the mathematical space, solid modeling. There of course we have different methods. For example, if you take AutoCAD, AutoCAD uses constructive solid geometry to build up the 3D model. And then maybe something else using different thing. Just before the CSG, we had this boundary representation. I'm not going to talk in details, but if anybody is interested, you can just read about these things for your information. And then we have the parametric representation. The constructive solid geometry, the AutoCAD thing is based on values, parameters. So for example, if I want to change the diameter, AutoCAD, it would be the most difficult thing. But the last one, the parametric representation, you represent those values as variables. We only need to change the variables. And combining all these things, we have even what you call feature-based modeling. After constructive solid geometry introduced by AutoCAD, and then we have this feature-based modeling. In SolidWorks, early versions of ProEngineer, even NX was those days ideas, Unigraphics and ideas, all these things, they use this feature-based modeling. In AutoCAD, what we do is we add geometries, circles, rectangles, planes, those are geometries. And then you combine them and then come out with different products. You mix up. It is something like you are preparing a cup of tea. You have the ingredients, tea, water, sugar, anything else if you want. You mix them up and then make a cup of tea. And after that, if you want to change something, say, I want to remove the sugar from that one. It's not easy. Maybe chemically it is possible, but I think it is not worth of doing that one. So that is how the constructive solid geometry works. Always thinking of the future, not thinking of the past. That is our usual experience. Right? But the design environment is completely different. In the design environment, sometimes you need to go back and then change something. If you do so, in early days, it would be the most unwanted that I want to do, because I have to repeat the calculations, do everything again. If I have even drawings generated or created manually, then I have to reproduce them. So then it comes this the parametric representation, where you store these values and you can go back to the history. So you remember the history, what I did before this step and even before the other step. Everything from the very beginning is going to store. And you don't have geometries, you have features, boxes, cylinders, holes, fillets, for example. They are the features. You are adding features and also you can remove features. You are adding features and you can remove features. So for example, there is a hole. You add the whole feature. The effect is you are removing material. Right? But it looks different for the feature-based modeling. You are adding a feature called hole. Then the material will be removed. When you remove the feature called hole, the material will be filled. So that is a different way. And for a long period, the feature-based modeling was the key topic. And you could see that we need to start thinking in a different line right now. In AutoCAD, we never think of what happened in the past. If you can patch it, we call it patch it, that's more than enough. Because everything is going to mix up. Like for example, the tea example, the first time you feel that the sugar is not enough, then you put something more until you get satisfied. But feature-based modeling is not like that. The order is important. The order that you create your features are important. Why? Because you're going to create relationships. We call the parent-child relationship. Parent-child relationships. Sometimes they are automatically created. Sometimes you purposely created. This is where the users get into difficult situations. How do I decide what sort of a parent-child relationship should be created at this point? Because you are thinking maybe several steps ahead. That is difficult part. That is the difficult part. At the same time, how do I identify what relations will be created automatically? Without knowing, if you start doing solid modeling, your model is useless. Perhaps you may be able to satisfy your today's requirement, but definitely not in the future. When you join an organization where one of these things, skills are very critical, then you will realize how important for me to learn all these things. That time it may be too late because you already have some habits, right? You already have some habits. And then the latest technology, what you call the direct modeling, is again you just without going through the what you call this the history-based modeling, you try to modify the part. You try to modify the part, and an extension of that one, bit advanced, is the synchronous modeling. In synchronous modeling, you can do much more than what you do in the direct modeling. I will give you some demonstration later. I'll start with simple modeling today, and then later I will even introduce what do you mean by the synchronous modeling, otherwise you get confused. So Siemens NX and Siemens Solid Edge both supports synchronous modeling. So direct modeling or direct editing or feature-based modeling, SolidWorks and similar software, you can see they are also supporting that one. Right? Again, a simple question, just to make you active. Why do we eat? Yes, different persons might have different requirements from different times. In the morning I eat for one reason, maybe during the lunch I eat for something else. But anyway, something will pop up in your mind. Although you are not going to think one after the other, the reason could be hidden in all these questions. So why do I display a slide like this? Because the next slide is more important than this. Why do you learn? One day you will join the industry, or maybe you will continue to your postgraduate studies and everything. Two different environments. Today in your university you are free, stress free most of the time. And you can imagine that you have almost like endless time, if not for the deadlines and other things. Deadlines can be extended, but our deaths cannot be extended. Right? Today I'm going to die, I cannot extend it for tomorrow. Right? So yeah, we are thinking in a different line when you are inside the university. But once you go to the industry, the objectives are different. You don't have time. You don't have excuses. You can't make mistakes. Because everything is money and time. It is very important for the industry. How do I switch from this free environment to that kind of a constrained environment? That is your practice and the habit. That is your practice and the habit. Otherwise, you won't be able to work in the industry. Or maybe you work, but there is no development in that sense. Right? So this is why we should learn. Not to complete this particular module. There much more work after the module. So you have to retain your skills and the experience and the knowledge that you gain through this experiment. Don't close your chapters. Your learning will never end. And after even more than 30 years, I'm still learning. I can't stop. I'm still learning. Right? There are new things coming up every day. So let me very briefly go through, but I'm not going to describe each and every step because it's not the objective of this seminar. You see, going back to early 50s, right, or 60s, we had something with much more difficulty. Right? Today you can imagine the situation. Right? So you can find these things if you go to the internet. Right? Development of these things. It is important for us to know where we are heading at. Maybe in 2 years' time, 5 years' time, where we will be. That is important. So then you can plan your learning or whatever it is. So if you are going to start a new organization, new company for the manufacturing or design, then you should know a little bit about the history and also the future directions. Otherwise, you won't be able to make it very successful. And then you see the ProEngineer, Autodesk, Unigraphics and CAD/CAM, like very advanced software those days, they ran only on what you call the mainframes, not on the personal computers. Not on the personal computers. Right? And then SolidWorks came, you can say, much later. ProEngineer was the first to acquire in the department. The first few batches were fortunate enough to learn the ProEngineer software. The cost of the software was actually at that time it was a commercial license in I think early 2000, something like $40,000. $40,000. This one license, right? And gradually we switched from that kind of environment into SolidWorks. You see, the first version is SolidWorks 95. We started using SolidWorks in 2004 or 5, I remember. At that time, the other software was not that popular in the Sri Lankan market. Right? Solid Edge also, you can see, it was, the original organizations who developed this software are right now maybe does not exist. They acquired, the Solid Edge was acquired by a different organization. Autodesk, you can see, earlier it was only AutoCAD, but right now they have a range of software. If you go to the website, you can see. Now even your mobile phone, you can at least open your 3D models, right? Whether it is Solid Edge, SolidWorks, or whatever it is, you can open that one. So now we are moving into the future. We should understand this, and also a bit of hardware as well. You can see how fortunate you are to use all these things even in your mobile phone today. These are the computers at the early stages. Now, we had this AutoCAD software in early 80s actually they developed, but the department got it in early 90s, which ran on an exactly similar computer like that. No hard disk, only floppy disk, and sometimes even not mouse. Right? You could see the AutoCAD screen. So definitely you are not going to use a software like this if it's available today. Right? Unfortunately or unfortunately, I used to start learning my things from a systems like that. Right? And then today, you can see the environment is completely different with a lot of hardware and facilities. You see the difference. Now, can you imagine what will happen tomorrow? We need to get ready for that, right? We need to get ready for that. So then, when you want to represent objects in 3D space, basically we use two different methods. One is called the raster images or the bitmaps, other one is called the vector graphics. You see the comparison of the raster and the vector graphics when you enlarge or compress the image. The bitmap images is going to lose its quality, whereas the vector graphics, it retains the quality. So in our CAD work, our design work, we use vector graphics. Means the data is stored as a mathematical model inside the computer. Whereas in the bitmap graphics, it is just the dump of your pixel map, whatever the combination of the pixel that you see on the screen, onto a file. So that is why you lose quality when you enlarge, because those become empty, void cells. You need to fill. There are, of course, some algorithms. Image processing algorithms are there, where you can improve the quality of this one, but that takes time. Whereas if you store them in as a vector graphic, nothing to worry about that one. So converting a raster image to a vector graphics may be not always possible, or you may not get even the required quality. But the other one is always possible. From vector to raster image, you can see. So what you see on the screen is a raster image. What is stored there in the computer, the soft file, is a vector image. So vector images are actually generated, not just dumped onto the screen. So you see the list of these things. I'm not going to get the individuals. So your vector image is very useful for you to decide those something. And other thing is, when you do 3D modeling, don't rely on what you see on the screen, because the screen has a certain resolution. Even if you take a 4K monitor, there is a fixed number of resolution. But when you think of the 3D model, so for example, Airbus 380, one of the biggest, how do I put everything onto this small computer? So what you see on the screen may be a kind of a generated one based on the number of pixels, we call the resolution. But we always maintain the vector graphics so that you can process it. And also, storing the data is the most important part. You usually store what you call the pixel data in raster or the bitmap images, and then rebuild the image on the screen by pixel mapping, 1 pixel by 1 pixel. If you have a pixel grid of 100 by 100, you store the same thing and then you regenerate on the screen. That's all. Right? So that is, sometimes your file can be bigger because you need to store a lot of data, depending on the resolution, we call it. Whereas vector images, nothing to do with the picture on the screen. Right? You store the data, the parameters, the formulas, the equations, or whatever it is. Then you can regenerate it. We call it, we regenerate it. So for a vector image, whatever that you can get is only what is available in the screen, unless you use zoom facilities through the software, otherwise it will be just a dump. Whereas in this case, no, you can process it. You can scale it. You can scale down or scale up. You can mirror it. You can section it mathematically and then generate the image again on the screen. That is what the vector images are. But for both raster and vector images, they are mostly proprietary. Someone owns this one, the content, although it is a bit open today, but those days I cannot open AutoCAD file from any other software. Right? And need appropriate software to open or edit the file. So if it is an AutoCAD file, maybe I need the AutoCAD file. Especially with this parametric software like SolidWorks, SolidEdge and other things, you may not be able to open a SolidWorks 2020 file from 2019 version. Its backward compatibility is not there. Forward compatibility is always there. Suppose accidentally you open that one from a higher version, and then when you exit, the SolidWorks is going to give you a warning. Do you want to save the file? You say yes, without thinking, because yes is always, you might think it is safe. But next time when you try to open that one from the important end, you may not be able to open it. Right? In a way that it is demanding the user to upgrade your software. Survival of the software development companies. But on the other hand, the technology advancement cannot be taken into the history because you have new things. Right? So you need to understand all these things, otherwise the product or the thing that you're going to design may be a useless design. And the next thing is the CAD data exchange. Someone is asking me, I think I remember, whether to use SolidWorks or SolidEdge. Today you can decide, maybe by the convenience, right? Or maybe because I'm familiar with this one, or I can easily access that one, or there are more tutorials for this particular software, or it is much easy. But tomorrow, once you are in the industry, you can't decide it like that. You will have to work with the available software. There may be some reason for the industry, a particular industry, to buy a particular software, but you have to understand the software if you want to join that company. Having said that, if you want to exchange your data between two organizations where they use two different software packages, then this data exchange is coming to the scene. Can I open a SolidWorks file in SolidEdge without losing all its data? There is a data loss, we call it. Right? There is a data loss. It's something like this. If I have a kind of a, say, paragraph written in English, maybe say the Shakespeare's English, how do I convert that one into Sinhalese to give the exact meaning? I don't think that it is possible. Even from a Sinhalese, to translate that one into English to give the exact message or whatever it is, it's going to be difficult. What do you call this one? This is a loss. There's an information or the data loss. Even when you exchange the data between CAD packages, this can happen, and you have to be very aware of these things. As a solution for this one, we have neutral files. If you can't open that one in a particular software, then what you do is you convert that one into a neutral file format, and then again convert back into the other software. A double conversion, more data loss. More data loss can be there. So when you start your design work, you have to think of all these things. At the end of the design work, if one component, one part, one team has decided to use SolidWorks, and then you decided to use SolidEdge or whatever it is, then you see there might be incompatibilities. Especially when it comes to manufacturing. It's very critical, extremely important. Because we are talking about accuracies, high-end tolerances and other things. You will not be able to maintain all these things. You will get unexpected results after that one. Right? So the native file, for example, AutoCAD has its own format. SolidWorks has its own format. Right? And neutral file formats like DXF, IGS, Parasolid, there are different formats available, which allows you to transfer data between different packages if they can't understand. But in most of the cases, you lose some of the data. So behind all these things, there is something called the graphics data kernel. Right? SolidEdge, NX, and other software is built on the kernel called Parasolid kernel. The Siemens owns it. They own the kernel. Whereas SolidWorks and other software are also based on that one, but they have purchased that one, licensed to SolidWorks to use. Right? So that is why still some deficiencies are there in SolidWorks like software when it comes to the modern modeling tools and the techniques, because you can't access the real power of the kernel because it is owned by the NX or somebody else. But anyway, irrespective of that one, my way is you have to learn all these things, because once you join the industry or somewhere, you might continue with something else. That experience is the important thing. This is the time you can play with those things, right? So the neutral format, and also you should have some kind of an idea how much is the loss that I'm going to accept, because especially in manufacturing, if you realize that one, after the manufacturing is over, the cost will be enormous, even be able to get back. Right? Design stage, you feel free. Right, again, one more session for the question and answers. You have any questions, any doubts, so that I can give you a quick or short answer? Do you think it is useful or no? Else I can skip all these things and then straight away get into the software. I'm telling you all these things based on my experience. Right? I have experience in all these software, so then I know how to compare, how to decide, how to select the advantages and disadvantages. All these things I can guess. I'm not just blindly using the software. Okay, I will continue again. So this is where I need to have a, what do you call this, the quiz. Okay. Do you want a break? Wait. It is not a break. I think it's a quiz break. Right? Dr. Hill, now I need, if I log in again, I don't know.
Still cannot. I mean, cannot see that.
I cannot see the polls here. That's why.
Okay.
If I, you can you get the, what shall we do now? I need those things. It's very important.
Then, sir, maybe.
Sir, you are the host now.
Yeah, but if I exit now, you all be disconnected, right?
If you
No,
exit, no, it won't happen.
No,
Then let me see.
somebody else will become the host.
Okay, I think
Probably
Dr.
Lihil.
Lihil also there. Okay, I'll try.
Janaka sir, just don't end it for everyone.
Okay.
Yeah, wait. Let me reclaim. Let me reclaim the host. Okay, now
If you regain the host, the same thing will happen. No, I will. Let's see. I will leave the meeting, right?
Lihil, try whether Ms. Janakamangal can be appointed as nominated as a.
He did
alternate
already.
host.
He did already.
Yeah.
So I'm leaving the meeting. I'm just.
Let's see if this works.
I still cannot see that one. Can you hear me?
Yeah, Janaka sir. Yeah, we can.
I cannot still see that one.
Okay.
What shall we do? Maybe we can continue without the quiz, or maybe because otherwise everybody will be disconnected, I hope.
Yeah, everybody will.
Yes, sir, we'll continue.
We'll
We'll
continue. Maybe
we'll save the research for next time.
yeah. I will start with the questions next time. Right.
Yeah.
Okay.
Maybe sir, we can put the quiz during the sessions of your sessions for the
Yeah.
module.
Yes. Okay.
Yeah.
Okay. Anyway, I have the question here, but not the responses are there. Okay. Let's imagine like this. You have 3 boxes. I want to see your approach. Right. The boxes are labeled as raw materials, products, and tools. You have a task. What is your task? You have to select a product, one product from the product box, and then select whatever the raw materials from the raw materials box, and then the tools from the tools box, and then you have to construct or fabricate the selected product. You got your task? Right. My question is this: which box do you open first? Can you at least raise your hand who's going to open with the raw material box first, so that I can at least get some idea? Only thing, I won't be able to show you the result. Those who are going to open from the raw materials box, I need your responses. Please raise your hand if you. Then the products, those who are going to start the products, I have given the same example for some of the students, but anyway, those who are going to start from the products. Yes, I see 1, 2, 3, not many. Yeah, okay, many. Right, so can I assume that the remaining is going to start with tools or no? Let's see now. Why do you going to start with products, or why do you going to start with raw materials, or maybe why do you want to start with tools? So whatever the box that you're going to open, what are the problems that you need to expect? So for example, I open the raw material box. I see some raw materials are there. Then I'm going to select something. Then I'm going to open the products. When we open the products box, you see that from the material that I have already chosen, I cannot make this product. Or maybe there are no such products in the box. So I need to go back and change the raw material. Right. Now I select the product and then the raw material, and I open the tools box. So then I need to select a tool that will be suitable to process the raw material that I have chosen. I might still have some difficulties, some problems, because the required tools may not be there. Tools are there for some of the materials, some of the products. At least there will be one match. Right? But the combination is not going to work unless you go into all 3 boxes simultaneously and then study them first. Right? So your 3D modeling is also the same thing. You need to study the part first. What is the purpose of this product? Maybe just to get a kind of a picture on the screen, or maybe I want to send that CAD data to the manufacturing division, or I want to calculate the volume, surface area and other things, center of gravity and other things. Or else I want to use this model to do a further analysis work, the finite element analysis work. Or maybe I want to create a virtual reality component out of these things. So your requirements you need to identify and study your product, what the product looks like, what features, the components are there. Can I take all the measurements? How do I start? And all these things needs to be there. Then you need to select the tools. and the raw materials. That is the software that I'm going to talk about. SolidWorks, Solid Edge, or maybe NX or anything else. Tools are there. How to, I mean, the raw materials are, for example, your building blocks inside the software. And then you do some operations on these things, and then you come out with different models. So you need to have a good understanding of how these things work and correlate. Otherwise, you won't be able to select. Say you want something and then you know only AutoCAD software, you start AutoCAD and then start modeling. Halfway through, you realize that you can't do that. Fortunate enough that if you can understand that I can't do this one in AutoCAD. But how do I select this right software, the tool? So for example, when you are working in the industry, a customer comes, very important customer comes and then going to hand over a job for you. Very expensive. You can earn much more profit from that one. You can't turn him down. You need to accept. So then your CEO or manager is asking from you, can you do this if I undertake this one? You know, you have SolidWorks, for example. Without thinking that much, without even looking at the product, you said, yes, we have SolidWorks, we can do that one. Now you undertake the job. And then what happened? You will not be able to use SolidWorks. Or maybe you have to put a lot of effort in generating the model. Don't think that because software is simple, easy, or complicated, because you are still at the infant stage of using this software. We are using only a fraction of the software, not the other features. By knowing only that much, you can't decide. You can't decide that one. That is why we need to have that experience. But anyway, the job has been undertaken. Now you need to deliver. What will happen? Either you deliver the product or you leave the job. Industry is so strict in that sense, right? Or you pay the penalty. So this is why. Okay, let's say now you're going to open all three boxes at once and then study well. Okay, I know this. Now, what else you need? What else you need? You have the software. You have the product already selected. Raw materials is there inside the software. I can use them. But if I don't know how to use the tool, I don't know how to use the software in a efficient manner, in a productive manner, then again I'm going to face some difficulties. It says it's a feature-based modeling, but in my model there are no features. Feature-based modeling, you say it's a feature-based model, but no features in the model. You understand? I know how to use the software, but it's like, we are using any tool like thing, for example, a knife. You just go to the web and type the different types of knives. Do you see any difference? For example, for us, knife is a knife. If it can cut, that thing it is, that's enough for us. But it is not. You need to go into the detail. You need to go into the bit of depth of the tool. So that is why this learning in a proper manner is very important. Otherwise, it's going to be very difficult. So with that, maybe I will start giving you a very brief introduction to Solid Edge for 3D modeling. Because Solid Edge can be used for different applications, but my task is to give you how you can use this Solid Edge software for 3D modeling. Mainly to fulfill the requirement of your machine design project. But anyway, for others, you can make this an ideal opportunity for you to start learning SolidWorks or Solid Edge, I'm sorry. So this is the scope, right? So initially it will be several seminars, and then after that we get into the regular classes. So if you see the learning outcomes, you can say they communicate design information through technical reports, engineering drawings, computer representations, except for this oral communication. Everything else we're going to handle through the software. And then the syllabus outline, you can say the two sections that we are mainly dealing with, geometric modeling part and the generation of the production drawings. But you cannot isolate, remember that. So for example, you have the detailed design calculation little above. You do some calculations and then based on that you're going to start the modeling. And after some time you realize that the calculation there's some mistake. Or maybe the customer is requesting you to change something. Luckily this will not happen in your model. But anyway, based on what you have selected in the previous steps, you may not be able to continue to the next step unless you change something. Inevitable, you have to go and change it. So that your geometric modeling cannot be isolated from the other things. Early days it was like that. You completed your design, we call the detailed design, and then hand over your work to the drafting division where the draftsmen were there to draw the drawing part. And then once you finish that one, somebody will check, confirm it is correct and then pass it over to the other division. We call it over the wall design. It happens over the wall. You pass your whatever your design work over the wall to the other department and then after that the communication closes. If any sort of changes are required, then there should be a proper mechanism. You need to come through again a proper path like that. But nowadays design cannot be handled like that. So for example, if you change your design calculations, your geometric model should be updated automatically. So that is why people started making what they call the parametric and the feature based modeling, history based modeling. With time, when the model becomes a bit complicated, then you see that thinking ahead of several features or 100 different features now is extremely difficult because you have to maintain what you call the relationships. The entire model is driven by those relationships. Geometric relationships and the parametric relationships are also there. So if you change something, the model will update according to the relationships. Sometimes the entire thing fails. You have 100 different features. Now just to acquire some design modifications, you need to go back to first few features and then change. Then what happens? Everything start failing. We call it the collapse of the model. In a software like AutoCAD, you can use at least the undo function. If you know that it's going to happen, in other software you can save it and then try it out. But you will never remember to save. Undo is not a reliable tool in geometric modeling. Don't rely on undo. Undo is there for an accidental things, few steps, because keeping inside somewhere in the memory the history of your modeling, the sequence and whatever the things that you have done is going to consume a lot of memory. Processing is extremely difficult. You erase, you move, you rotate, right? And all these things, if you want to undo, then you have to remember these things. So this software, that is why history is there for you to go back and change. But what happened, unfortunately, for sometimes, if one of these relations fails, there will be some mathematical bugs inside because the developers cannot check all these things. The software exits all of a sudden, not allowing you to even think of or even save. You lose everything. Now when you open the model next time, if you are fortunate, you might have the backup file created. But the software is again allowing you to choose that one. It's your option. It's your choice anyway, to leave it or not. Right? Sometimes you lose everything. Or maybe your file is corrupted already. File is corrupted, data is corrupted, but still you can see something on the screen. The most unfortunate thing is you will not be able to understand whether the data is corrupted or not. Right? And for sometimes, so for example, in a package like this, AutoCAD for example, sometimes you save twice for additional safety. additional safety. In some software, it's extremely dangerous. You know what happened in AutoCAD, even the other software is also the same thing. There are 3 versions actually. The software maintains 3 versions at a particular time. One is in the hard disk, which you can open at any time. Other one is in your what? RAM. RAM is the one you are working your dynamic area. So what is the third display? What is the third area? The software will make an automatic backup, we call. The software is supporting the automatic backup. Is going to save your file from time to time in a predefined interval, say 1 minute, 10 minutes, 1 hour, something like that. So there are 3 versions. So one in the hard disk will be different from one in the memory, and then one in the automatic backup locations. Right. Now let's say at one time you decided I want to save the file. So then what will happen? Whatever that is in your RAM will be put into the hard disk. Right. And then the auto backup area will be cleared because you don't need that one because you're going to save it. And then whatever that was in the hard disk will be put into the backup file. Right. So one operation has gone. And then you save it again. Then what happened? Because it is the same thing. It is the same thing. What is the RAM is now will be replaced with the hard disk content. And what is in the hard disk, the backup will be replaced by that one. Now all 3 versions are the same. All 3 versions are the same. You lose everything and now you have only one version. If it is in the normal situation, it's okay. But say for example, you start doing something and then realize something is wrong. I can't even undo. If I undo it, something else will happen. So I want to exit and then come back. I want to exit and come back. When you try to exit, software will ask, do you want to save? Now you have a doubt. Right? For additional safety, you might say yes. And then for the second time when you open, because the file is already have some difficulties, you are again going to get the same problem. You exit, excuse me for this noise. Right, so second time when you open it, you might encounter the same difficulty and then you try to exit again. Software will ask the same question again, you say yes again. So in all 3 places you have the corrupted file. Right? You see how important it is even to know all these background processes? The best advice that I can give you is, if you have any difficulty, first thing that you should do is take a copy of your file in the hard disk and make sure your backup location is accessible. Right? Sometimes it can be directed to a different network or pen drive which has been already removed, so the backup operation will not be taken place. Right? So all these things are important, especially for this design project, because don't complain at the end. Right? My computer has already broken. Hard disk is gone. Pen drive, I lost my pen drive. I generally don't accept this kind of excuses, because I will tell you exactly how to protect them, so that I'm expecting no excuses from you. It is on good, right? On safety. Okay, so let's start like this. What is Siemens Solid Edge? And then the user interface, bit of introduction to user interface, and then how to model some simple parts, and then how to edit the features or the parts that you have already created. And if time permits, I will go into the different modeling tool, give you an introduction, and then the next seminar I will take those things and then show you how to create different parts in different ways as well, not only one method. The disadvantage I realized in some of the YouTube videos and the books, especially the very good books, because they discuss only one method. Otherwise, you will never be able to close your book. several chapters will be there, or several revisions, editions will be there. It is up to you to try out different ways. Right? So I will show you by taking different components how to model the same component with different approaches. Then you will be able to identify what it means. Right? So before I start, I will show you a small video which I have created for the the previous batch. I started creating simple models like this. I started in a very simple manner, and this is the last thing that you can see. So I'm expecting same or similar thing from you as well this year. So this is how you can communicate to a person, a non-technical person, what the product looks like, right? And also it will help for the person who is going to maintain assembly, right? To see the sequence, which is also very important. How the mechanisms are going to work. Right? And at the same time, I will show you some of the work completed by the students as well. So this is one of the products. Can't accept this level of work. It's only a few hours of effort, right? It's only a few hours of effort. That is one thing. And maybe very quickly I will show you. These are the final submissions. You saw in my first video the quality and the level of thing that we are expecting, and this is what they have submitted, right? And also I will show you something much better than the two previous ones. I never check their modules separately or the models separately. Only thing, the instructions given during the lecture, that's all, right? So students managed to come out with this thing, and maybe this one also. From outside it looks okay, but inside it is completely unacceptable because you can't assemble this thing. You need to understand when you say assemble gear wheels, shafts, bearings together, where we need to be more precise. Manufacturing, right? So this is also they are like this, and then like this. These are of course the students' work, right? Not my work. You see, this is also the something similar to that. I will tell you why these models are not suitable for a gearbox or whatever it is. You have to think of the manufacturing, the possibilities, limitations, and ultimately what kind of accuracy that we can obtain. Right? And above all, I will show you even this one. This is not my work. This is again one student's group work. You see the difference, right? So that means it is possible. Even for you, it is possible. Right? I never personally help them to generate all these things. Right? So it is possible. This was the group number 1, I hope, in the last year. So when I opened this one the first time, then I was very happy to see more of such models like that. You see now everything. If one student group can have time, can find time, why not others? So that is why my advice is don't wait until the last minute. Then you don't have time. Right? Then you don't have time. Right. So before I start, maybe we'll take a small break because it's almost 2 hours gone. Right? So is it okay if you take a, say, 10 minutes break now?
Yes, I think we can take a break. Yeah.
Okay, so we'll meet in approximately 10 minutes time.
Okay, 5:15.